In this particular video, I want to go over the solutions for problem 13 and 14. And I'm going to be using the PC environment, not the Mac environment. But in this particular case, for problem 13, you can see I've indicated it just pretty much the way it was laid out in your text for problem 13. We identify the first grade and the final grade in rows. The problem is, and when dealing in regression, we really should look at it from the columns perspective. So therefore, we're going to have to transpose rows to columns. And in Excel, that's not too difficult. So the first thing we want to do, we just want to indicate the range that we have. And then we want to just identify a column. Let me go back, put the range in, and then go Control C, and let's put it in L and M. Right click, and you can see our paste options, and here transpose, and there it is. So now, okay, we can go to our work data, our data analysis. We're going with regression, and from this standpoint, let me just kind of get rid of this. So cause and effect in regression analysis, as we indicated, I should say, as I indicated in my lecture, regression analysis, we utilize it to forecast. There's a cause and effect. So in this particular problem, we want to forecast the final grade based upon what one earned on the first. Final, we don't know. We want to be able to forecast based upon first. So therefore, the final grade is our dependent variable. The first grade is our predictor variable, independent variable. I know some of you just kind of got this reversed, but think of it from that standpoint. We want to base our forecasts on what the final grade should be based upon the first grade. So we got to do we want to put the range for our dependent variable, and then we want to identify the range for our x or independent variable. Always mark labels, right? Mark labels, and then we'll put it into a new worksheet. And when we do that, this is our summary output that we talked about. The summary output gives us an R-square of 84.7%, coefficient of determination. As I explained to you in class, what this really means is that approximately 85% of what is going on in these final grades, it can be explained away by using the grades on the first. So therefore, there's approximately 15% that we cannot explain. But the coefficient of determination, R square, is 85%. So when we come down here, and also wanted to do is, okay, is it significant? And this goes into problem 14 with the p-value. And you can see the p-value is 0.000431, which is definitely less than the level of significance. Therefore, there is a significant relationship between final grade and first grade. If we come over here, I can just identify the equation as such, and the equation would be final grade is equal to our intercept, 18 point, we'll just say 99, plus the slope, 0.73 or 74, times the first, we'll say first grade. That is our so-called regression equation. Now, if we wanted to forecast what the final grade would be, as in the text, we would simply insert that value here, and multiply it by 0.74 and add back in 1899, and we would get something like 80. So that's pretty much the overall solution for problems 13 and 14, with the reminder from the standpoint that how the data was presented in the text, we had to really transpose or make rows go to columns.